let's start by looking by setting our ground node. You know the ground node will be 0 volts here. Now, let's say that there's a current moving in this direction. So since we're exiting out the positive terminal, there's a voltage increase. So it goes from 0 plus 20 volts, and our whatever we get from this answer, that'll be the voltage at this region. So 0 plus 20, that's 20 volts. So that means it's 20 volts here. Now, if our current was to continue going, we see it exits out of positive terminal, so that means there's a voltage increase. So what would this region at this point be? It'll be 20 plus 25, which is 45. So at this region, it'll be 45 volts. Now, if we were to continue going in this direction, we notice that we exit out of the negative terminal, which means there's a voltage decrease. So it'll be 45 minus 10, which is equal to 35, which is a region right here. Now, we can solve for V1. If we were to go in this direction, we know that there will be a voltage increase. So it goes from 0 plus V1. We don't know what V1 is, but we know it equals 35, okay? Because that's the region we get at the end. So 0, okay, it's pretty obvious what this is. V1 is 35. So that just like that, we already solved for V1. V1 is equal to 35 volts. Now, let's find this region, then we can solve the rest. We see if there was a current moving in this direction, it exits out the negative terminal, and we know we started from the 45 volts. This goes from 45 volts, then this is exiting out the negative terminal, it's negative 15, and that's equal to 30 volts. So that means it's 30 volts right here. Now, let's say there was a current moving in this direction. It goes from 0 plus V3 equals 30 volts. So that means V3 is 30 volts. Now, let's say there was a current moving in this direction. It'll be 30 plus V2, that it will equal to 35. Let's bring the 30 to the other side. So it becomes V2 equals 35 minus 30. And that gives us 5. So V2 is 5. And those are your answers.